Hello learners and welcome to a Natural Sciences lesson. So today we are dealing with chemical reactions, and within that we're going to be answering questions based on the chemical reactions. So let's start. The first question given to us is, write each of these descriptions as a word equation. We are given that calcium, and we know from the periodic table that calcium has a chemical formula of Ca. So calcium reacts with chlorine. Remember, chlorine is part of the diatomic molecule, so it's written as Cl2 to form calcium chloride. So we need to write this as a word equation. So this is going to be calcium as one of our reactants. Remember, we're separating the reactants with a plus sign. So calcium plus chlorine. Remember, reacting to form, it is an arrow, reacts to form calcium chloride. Calcium chloride. Then we're also told that we get lithium oxide when lithium reacts with oxygen. So the lithium oxide is what is produced when lithium reacts with oxygen. So therefore, lithium oxide is the product. Then the reactants are the lithium and oxygen. So this as a word equation, we say lithium plus oxygen reacts to form lithium oxide. Moving on. Now, this question, we are given a chemical formula, a chemical equation that is in terms of chemical symbols. It says that this reaction turns a clear liquid milky, and there are two products in this particular reaction. And also, by looking at this reaction, we're seeing that we also have two reactants. So we have two reactants and two products. So question 1 says that, give the chemical formula of the two reactants. So our reactants, remember, they are written before the arrow or on the left-hand side of the equation, or the left-hand side of the arrow. So these are going to be our two reactants, and these are going to be our two products. So our reactants are, we have Ca bracket OH, close the bracket, 2. We also have CO2 because those are written before the arrow or on the left-hand side of the arrow. Then the products, because the next question is asking us to give the chemical formula of the two products that are from this particular chemical reaction. Products are written on the right-hand side of the equation, so therefore it's this one and that one there. So we have CaCO3, our calcium carbonate, and our most famous compound or molecule being water, the H2O. So those are going to be our two products. Next question. It is a continuation from that because we are still given the very same chemical equation, and now we need to complete the table by counting the number of atoms of each element on both sides. So we need to check how many atoms of this particular element do we have on the left-hand side and also on the right-hand side. So calcium, Ca, remember calcium is Ca, oxygen, it is O2, hydrogen, it is O2. Remember that these two are part of the diatomic molecules, and then carbon is C. So how many calciums do we have on the left-hand side? So this is your left-hand side here. How many do we have? We only have just the one, so it is 1. Then on the right-hand side, this is your right-hand side. How many do we have? Also just 1. Now oxygens. How many oxygens do we have on the left-hand side? Remember, when we are given this particular or something like this, OH with the 2 outside the bracket, that 2 stands for everything inside the bracket. So that means we have 2 oxygens, we also have 2 hydrogens. And still, within the left-hand side, we also have these ones. Remember, this is a subscript that only stands for the oxygen. So we have 2 oxygens here. We also have 2 oxygens there. So in total, we have 4 oxygens. Where? On the left-hand side. Then on the right-hand side, again, we have the subscript of 3, so it's 3 oxygens, and then there's a subscript of 1. Remember, if there's no number, the subscript is 1. So it's 3 plus 1, still 4. Then hydrogen. How many do we have on the left-hand side and how many do we have on the right-hand side? On the left-hand side, we calculated that we have 2 hydrogens. And then on the right-hand side, remember the subscript stands for that particular symbol, which is the H. So we still have 2 hydrogens. Then carbons. Left-hand side, we don't have any carbons here, and our carbon is only this one here. So it's only just the 1 carbon. Right-hand side, we don't have carbons here, and our carbon on this compound, the calcium carbonate, is only just that one. So we also have 1 carbon on the right-hand side. Next question. So we now need to select symbols from the list provided to complete the chemical equations below. So we have O2, the arrow, Na2O, Mg, the plus sign, and also O2. Then the first chemical equation is saying sodium reacts with oxygen to form sodium oxide. So sodium, it is Na, we know, reacts with, this means it must be added to something. So Na plus, so our first symbol is going to be the plus. Na plus O2 reacts sodium oxide. Sodium oxide is given from the list provided. So this is going to be capital letter A, small letter A, capital letter N, small letter a, and the subscript of 2 and O. And then our second question says, zinc reacts with oxygen to form zinc oxide. So our reactants are zinc and oxygen. They are added together, hence the plus sign. So our oxygen from the list is O2. They are going to react together to form something. When they are reacting together, we need to show that they are reacting by means of an arrow. So they are reacting together to form zinc oxide. So our chemical equation is going to be that zinc plus O2 reacting to form zinc oxide. So our next question is still a continuation of that first question, whereby now we are still selecting from the list that is provided in order to complete the chemical equation that is given to us. We are told that magnesium reacts with oxygen to form magnesium oxide. So from this list, we know that magnesium has a chemical symbol of Mg, capital letter M and small letter G. So it's going to be Mg plus oxygen. Remember, oxygen is a diatomic molecule. It has a subscript of 2, reacting to form MgO. You will notice that this reaction and these 2 reactions, they are not balanced. You notice that the number of the atoms on the left-hand side are not equal to the number of the atoms on the right-hand side. We are still going to deal with the balancing of chemical reactions. So we are going to quickly take an ad break, and I will see you after this.